Can't remember.
Yeah, I've told you that the theorem, the number I've given to them does not really matter. Is that clear?
Okay.
So, but in my own case here, I'm going to define theorem 2 as a tangent to a circle. A tangent to a circle is perpendicular. A tangent to a circle is perpendicular to the radius at that point. A tangent to a circle is perpendicular to the radius at that point. So what does that mean? It means that, don't forget I told you that a tangent is a line that touches the exterior of a circle. So this is the circle. So you are going to have the tangent here. This is a tangent. This is the center of the circle. So from the center of the circle to this point, so what we are saying now, this is radius. So it means that this radius and this tangent are perpendicular. Do you get that now?
Yes, sir.
Similarly, if you have another radii here, then you can also have another tangent here. This is another tangent. So this tangent and this radius are also perpendicular. I believe you know what perpendicularity means.
Yes, sir.
That means they are 90 degrees to one another. So this is tangent. This is also tangent. So that's what that theorem is saying. So quickly put it up. Then we'll now see example. Number 1. The question says find E in the figure below. So the figure is this. Have a tangent. So this place is 36. Then this is E. Hope you can see what I've written here. This small angle here is 36. Can you see that?
Yes, sir.
Okay. Now, the question said we should find E. So how do we go about that?
Uh, First, we label the right angle.
Okay. So let's label it first to make it easy. If you label it, let's say this is O, let's say this is A, then this is B. So we can say that OA, let's say this is T, is perpendicular to AT. Do you agree with that?
Yes, sir.
So meaning that if I say that E plus 36, that should be equals to 90. Because the whole of this angle from this radius to the tangent is 90. Do you get that now? So E plus 36 is 90. So that E will now be 90 minus 36. And that gives us 54. So angle E is 54. Is that clear?
Yes, sir.
Okay. Let's see another one. I want you to try that. Number 2. Sorry, this will be a straight line. Yeah. This is a straight line. Then you have this angle here, angle S. You have this angle here, 69. The question now says find S. So I want you to try that. Are you doing that?
Yes, sir.
Okay.
Times display. That's 90. That's 90.
You're done?
No, I'm still working it out. 16. Is S21?
21. That's correct. Can you explain how you obtain that?
So first, if we label the tangent A, angle OA would be a right angle.
Yes.
And if we do 90 minus 69, we get 21. and S and 21 are equal, so are
Because
equal.
that
So
triangle is formed by two radii. Very
the
good.
triangle is formed by two radii.
Yeah, correct. Very good. So, okay, let's move on to theorem 3.
That's nice.
Theorem 3. What does theorem 3 say? It says that,
Oh, oh,
okay, you want to try?
I was going to say an angle at the middle is twice the size at the angle at the circumference.
Okay. Yeah, in my own case, I did not call that theorem 3. So we are still coming there. Very good. That was one of the theorem. Yes. I'm going to take that at theorem 5. So let's look at theorem 3. Theorem 3 says that the angle in a semicircle the angle in a semicircle is a right angle. The angle in a semicircle is a right angle. What does that mean? 90 degree. The angle in a semicircle is a right angle. So this is what we are saying. You have a semicircle. So we are not saying that this is the center of the circle. The angle that faces the center is 90. So that's what we are saying. So in a semicircle, the angle that faces the center, the way you have it here, is what we are saying is 90. So if you look at it, it's like you have a triangle curved out in a semicircle. Do you understand that now? So this line is a chord. This other line is also a chord. So the meeting point of the two chords is what is forming the 90 degree. So let's say example.
That your alarm on actual chicken.
My chicken. Sorry for disturbing you.
That's all right.
So this place is J. This is J. So the question now says, what is the value of K? What is the value of K? Can you try that?
Yes, sir.
Eh?
Okay. The angle.
We do it together.
Uh, yes, sir.
Okay. So the first thing you are going to do now, you will see that let's label it. Let's put O here. Let's put A here, B here, then C here, then D here. A, B, C, D. Now, if you look at it, you can see that BD is a straight line. Or you want to say BC is a straight line, whichever way. But I would prefer to say BD because it's the line from B that extends to D. Do you understand that now? So because BD is a straight line, I can now say that J plus 132 equals to 180 degree. Sum of angles in a straight line. Ló ń ṣe pẹ̀lú nǹkan tó ń jábọ́ bẹ́ẹ̀ báyìí. Sorry, please. So J will now be 180 minus 132. So J will be what? 48. Understood?
Yes, sir.
Okay. Now that we have determined J, and this is a semicircle. If you look at BC, ABC, or you want to say BCA, BCA is a semicircle. BCA is a semicircle. Do you get that now? So reason why we can say angle in a semicircle is 90. So this place is 90. So I will now treat BCA as a triangle. Or you want to say BCA is a triangle in a semicircle. If you want to put it that way. Let me put it that way. I think it makes sense that way. BCA is a triangle in a semicircle. Is that clear? So I can now say that K plus 90 plus J equals to 180. Sum of angles in a triangle. You know, I told you, you must state your claim. You must state the theorem, the rule you have used so that you won't deprive yourself of marks. Is that clear?
Yes, sir.
Okay. So K plus 90 plus 48 equals 180 degree. So K will now be 180 minus 138. And that gives 42. So angle K is 42 degrees. Does that make sense to you?
Yes, sir.
Any question?
No, sir.
Okay. So when you're done writing that, let me know so that I can open another page.
I'm done.
Okay. So let's see another page. So this time we'll now look at theorem 4. Now, theorem 4. What does theorem 4 says? Theorem 4 says that a diameter is a perpendicular bisector a diameter is a perpendicular bisector of a chord. A diameter is a perpendicular bisector of a chord. That is, diameter divide a chord into two equal parts. Do you get that theorem? He said diameter is a perpendicular bisector of a chord. So let me draw it so that you understand what that statement is saying. What do we say a chord is the other time? So this is the center of this circle.
You said the chord is a diameter that is a diameter but doesn't run through the middle.
No. A chord is a line that touches the circumference of a circle at 2 points, but does not pass through the center. But a diameter is a line.
Basically diameter as well, but doesn't pass through the middle.
Diameter is a line that passes through the center of the circle. Is that
But I
clear?
said it's a diameter but doesn't pass through the middle.
No, don't use the word is a diameter. Once you say it's a diameter, that means it's passing through the middle of the circle. It's better you say it's a line. Are you with me now? That touches the circumference of the circle but does not pass through the center. Am I communicating?
Yes, sir.
Okay. Now, this is a chord that I've drawn. Now, and I want to put a diameter to it now. So this is diameter. So what that theorem is saying is that it will now divide this chord into two equal parts, meaning this side and this side are equal. And it's a perpendicular bisector. That means this angle here is 90. This angle here is also 90. Am I communicating?
Yes, sir.
So that's what that theorem is saying. So this is diameter. This is chord. So a diameter is a perpendicular bisector of a chord. That is, diameter divides a chord into two equal parts. So please catch that.
Done.
All right. So let's see example. The question says, find the value of C in the diagram below. Make sure you draw your own to be perfect. So that's the diagram. When you are through drawing it, let me know.
I'm done.
Okay. So how do you intend to solve this now?
Uh, Semicircle. Is let me. Okay. Is this angle here is like the angle at the top?
Okay.
Is it
Okay.
a right angle because of it like a semicircle?
You mean this C?
Yes. It is.
No.
But is it?
Don't use that. You can't use that theorem. Now, this is the center of the circle. You can see that there's a line that passes through the center of the circle. And you can see that this line that passes through the center of the circle meets this line, which is a chord. You are not concentrating. Are you tired?
No, I'm just stretching.
Don't worry. Let's finish this. I will allow you to take a walk.
Yeah, it's good.
So this is a chord, right? This is a chord. So to make sense, let me label it. If I say this is A, this is B, understood? So AB is a chord. Then let me put D here. Let me put D here, then put E here. So I will now say DE is a diameter. Is that clear? DE is a diameter. AB is a chord. Now you can see that it's me that is fleshing up the problem to make life easy so that I can apply appropriate theorem. So since DE is a diameter, so DE divides AB into two equal parts. That is a perpendicular bisector. So meaning that this place is equal to this place, and this place is going to be 90. So this place is going to be 90. Is that clear? So
Yes,
if this
sir.
place is 90, then I can now use sum of angle in a triangle. So 37 plus 90 plus C equals 180. Sum of angles in a triangle. Is that clear?
Yes, sir.
So, and that gives what? 180, no, sorry, C equals 180 minus 90 plus 37. That's 127.
127.
So 127, 180 minus 127 give us
That's
53, right?
53.
Yeah. So angle C is 53. So we have less than 10 minutes. So write that quickly.
Done.
Easy.
Excuse me, sir.
Okay.
Why don't you use Google Meet instead? I don't think that one has a timer.
Okay. Maybe next class we'll try that. You
Okay, sir.
understand that?
Oh, yes, sir.
Okay. But does that one has a whiteboard?
Um, I don't think
Okay.
so.
I will check it. I will check if it has. So I want you to do this quickly. We are going to do this one exercise. Make sure your own is straight. Easy. Okay. The question says, find the value of A. So quickly do that.
Is it one? Is it 73?
Yeah. I've helped you with the information I provided, right?
Yes, sir.
Okay. Laptop charger. Plug it on extension. So very good. So let's quickly look at theorem 5. What does theorem 5 says?
Theorem.
The angle subtended at the center of a circle is twice, or you want to say double, the angle subtended at any point on the circumference. At any point on the circumference by the same arc. By the same arc. Now. Hope that statement makes sense to you. The angle subtended at the center of a circle is twice the angle subtended at any point on the circumference by the same arc. I'm going to give you two diagrams. To drive that home. A, B, and C. So C is X. So that means This place is 2x. So what is the same arc that we are talking about here? The arc is AB, arc ACB. So in that context, it means that AOB equals to 2ACB. AOB equals to 2ACB. That's what that is talking about. The another one is this. So in this case, I can do this. So if this is B, then this angle here will be 2B. Then if this place is A, then the angle here will be 2A. So for the one that is B, you are looking at this arc. For the one that is A, you are looking at this arc. And that's why we have said by the same arc. Does that make sense to you?
Yes, sir.
Okay. So when I don't drawing that, let me know. Are you through?
I'm almost.
Hurry up, we have less than 1 minute.
I'm done.
All right. So the thing will off now, then you just relog in. So I will now give
Okay.
you example when you log in again. So you can stretch. Let me allow you to take a walk. Just take a walk.
Oh.